Hello my dear students, I warmly welcome you to CR Digital Classes. In this lecture, we are going to discussing about one of the important topic for the short answers, subsequential limit points. Okay, for the examination purpose, this topic is very important. Why? Because in the previous examinations, so one of the question came from this topic. Okay, so let's see the question first of all. Find the subsequential limits of the following sequence. Okay, so the first question is S suffix n is equal to sin n pi by 3, and the second question is S suffix n is equal to cos n pi by 3. Here we have two trigonometric functions. For those two trigonometric functions, okay, for those two sequences, we have to find out the subsequential limits. Okay, so if you observe carefully the problem, you know very well limits, okay, but you don't know the word subsequential limits. Okay, so first of all we have to know the definition of the subsequential limit. After that we can go to the solution of the two problems. Okay, for the previous examination, that is 2022, so this S suffix n is equal to sin n pi by 3 have come in the examination. Okay, in the short answer purpose. For the examination purpose, this concept is very important. Subsequential limits, not only these types of trigonometric functions in your textbook and material, so there are a lot of problems based on these subsequential limit points. Okay, so if you see these types of problems, you can do those problems also. Okay, so now we'll start with the definition first of all. Okay, so subsequential limit, see the definition. If S suffix n is a sequence in real numbers. Okay, so S suffix n is a sequence in real numbers, and a real number or symbol plus infinity or minus infinity is called subsequential limit. Okay, so a real number or the symbol plus infinity and minus infinity is called as subsequential limit of the given sequence S suffix n if it is the limit point of the some subsequences of S suffix n. Okay, so that is called subsequential limit definition. Okay, so what he is mentioning that whenever you take a sequence S suffix n, okay, in the field of real numbers, then for every sequence there exists a limit point, either it converges or diverges. If it is converges, if the sequence converges, then limit point will become a real number. Okay, so limit point become a real number. Or if the sequence diverges, then the limit point should be plus infinity or minus infinity. Then, okay, so whenever a sequence has a limit point as a real number or the symbol plus infinity minus infinity, then that is called subsequential limit of the given sequence if it is the limit point of some subsequences of the given sequence S suffix n. అంటే ఆ సీక్వెన్స్ కి లిమిట్ అవ్వాలి, లిమిట్ పాయింట్ అనేది మెయిన్ సీక్వెన్స్ కి లిమిట్ అవ్వాలి. ఎట్ ద సేమ్ టైం ఆ మెయిన్ సీక్వెన్స్ కి సబ్ సీక్వెన్సెస్ ఉంటాయి మనకు, ఆ సబ్ సీక్వెన్సెస్ కూడా అది మనకు లిమిట్ పాయింట్ అవ్వాలి. Those types of limit points are called subsequential limit points అని చెప్పేస్తాం. Okay, so that is the definition. Now you can see either another note. If a sequence has a limit s, okay, then all the subsequences have limit same s. So flower bracket s is the set of subsequential limit. Okay, so here for example, if you take a sequence S suffix n, for this sequence if you have limit point is small s. Okay, for the same sequence you will get subsequences S suffix n suffix k in this format. For these subsequences also, if you get the same limit point, then you will get some collection of limit points. Okay, that collection of limit points is called subsequential limit points. అంటే సీక్వెన్స్ కి మెయిన్ సీక్వెన్స్ కి సబ్ సీక్వెన్సెస్ కి లిమిట్ పాయింట్స్ ఎగ్జిస్ట్ అవ్వాలి. దట్ లిమిట్ పాయింట్ షుడ్ బి ఇన్ ద డిఫరెంట్ ఫార్మాట్. దట్ కలెక్షన్ ఈస్ కాల్డ్ subsequential limit point of the given sequence. Okay, so we are calling it is, we are defining the definition of the subsequential limit point in this method. For the examination purpose, whenever you get a question based on this subsequential limit point, so first of all you have to write down the definition of the subsequential limit point. Okay, in the example we can solve the problem. Okay, so that is the definition of the subsequential limit. Now we can solve the given two problems. Okay, so first of all see the first problem. Given sequence is S suffix n is equal to sin n pi by 3. Okay, so this total sequence exists in the real numbers only. Okay, this sequence belongs to say a field of real numbers and the function is trigonometric function. So you will get algebraic function. Algebraic function means you will get in this format: Sn is equal to n square plus 1 by n cube minus 5. These types of all functions are called algebraic functions. If you get a sequence s of xn is equal to exponential or s of xn is equal to logarithm functions, okay, or transcendental function, if you get a different functions, the procedure will be same for the to find the subsequential limit points. In this lecture, we are going to discussing that one trigonometric function. Okay, for the trigonometric function, we are going to find out the subsequential limit points. Okay, before going to start this solution, you need to know some basic concepts in the trigonometry. Okay, so what are those basic concepts? So first of all, you know very well in the intermediate level also. This is the 2D dimension. First quadrant, you can call it as first quadrant, and second quadrant, third quadrant, and this one is a fourth quadrant. Okay, so x-axis and y-axis. Here, whenever an angle rotates around a circle, so it will start with 0 degrees. Okay, if it is goes to up to here, so it will become 90 degrees. Okay, 90 degrees means you can write angle in this format, and the same angle comes in the down format, so then you will get here 180 degrees. Okay, so from here to here it will get 270 degrees angle, and again from here to 0, so 0 is equal to 360 degrees. Okay, so here all angles are the multiples of 9 table. 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36. Okay, if it is repeats again, okay, 9 fives are 45. In this format again you will get the angles and matter. So now for 0 degrees equal to 360 degrees, 90 degrees is equal to 450 degrees. Okay, so in this format you will get different angles. For each and every angle, here 90 degrees we can write pi by 2. Okay, so and 60 degrees we can write pi by 3. Next to 30 degrees we can write pi by 6 in this format, and 45 degrees we can write pi by 4. Here pi is equal to 180. You know, pi is equal to 180. 180 by 2 is nothing but 90 degrees. You know very well this base concepts. Now why we are discussing this total trigonometric table means, so whenever you get a question from the trigonometric function, definitely you need to know the sign of the given trigonometric function in the which quadrant. Okay, for example, if you get first quadrant, here all trigonometric function get the same sign. Okay, all trigonometric functions from sine theta to cosecant theta, and from tan theta to cot theta, and cos theta to secant theta, all 6 trigonometric ratios will get the same sign, that is all trigonometric functions will be positive here. The angle in this first quadrant is 90 minus theta. Okay, 90 minus theta. Okay, so therefore next in the second quadrant, you can write here 180 minus theta, 90 plus theta, 90 plus theta and 180 minus. That means from 90 degrees to 180 degrees, the theta will exist in that second quadrant. Here only sine and cosine. Sine and cosine angles only positive. Rest of the trigonometric functions will negative. In the next third quadrant, 180 plus theta, okay, and 270 degrees minus theta. Those are the angles. Okay. In this third quadrant, only tan and its opposite ratio cot. These two ratios only will get the positive signs. Rest of the 4 ratios will get negative sign whenever finding the value of the theta. Next to this, the third quadrant, 360 minus theta and 270 plus theta. 270 plus theta. Okay, so here cos theta and secant theta. These only two ratios will get positive sign. That means plus symbol, and the rest of the 4 ratios will get the negative signs. Okay, so now to know the subsequential limits of the given sequence, you need to know how to find the values of the given sequence. Okay, so this is the basic table for your understanding level. Now we can start the solution. For n is equal to 1 in the given sequence, you will get the first sequence s of x1. S of x1 is equal to sine n pi by 3. N is equal to 1 means pi by 3. Okay, so pi by 3 means you will get 60 degrees. Sine 60 degrees, you know very well, root 3 by 2. root 3 by 2. Next, for n is equal to 2, we can write s suffix 2 is equal to sine 2 pi by 3. Okay, 2 pi by 3, that is actually sine 120 degrees. That 2 pi by 3, to know that sine theta value, so we are writing in the 180 minus theta. Okay, sine of pi minus theta. Pi is nothing but 180 degrees. Okay, so you can see here 180 minus theta is the second quadrant. 180 minus theta is the second quadrant. So sine 180 minus theta is in the second quadrant. Whenever you have the angle is even angle, then the ratio sine will be sine only. Okay, whenever you have odd angle, then ratios will interchange. Sine will become cosecant and cos will become secant in this format. Okay, so therefore sine 180 minus theta, so sine will become sine only, and 180 minus theta is second quadrant. Sine of the angle, sine of the ratio is plus, and sine theta only. Here in place of theta we have pi by 3. Okay, sine pi by 3, that means sine 60 degrees. Okay, we have root 3 by 2. In this format you can get the values. Here you can see here sine pi minus pi by 3. Okay, so pi minus pi by 3, if you simplify them, if you take the LCM, 3 pi minus pi by 3, so again you will get 2 pi by 3 only. Again you will get 2 pi by 3 only. So that 2 pi by 3 value only we are converting in the trigonometric ratio format. You know very well the total expression how we can express. Okay, so therefore, so sine 180 minus theta, again you will get sine theta only. Sine here in place of theta we have pi by 3, 60 degrees. Sine 60 degrees, again we are getting root 3 by 2. Next, for n is equal to 3, s suffix 3 is equal to sine 3 pi by 3. Wherever you have small n, substitute that natural number n is equal to 3. 3 pi by 3, 3 will get cancelled. Sine pi, sine 180 degrees. For all the even numbers, sine theta value will become 0. Why? Because sine 0, 0, sine 180, 0, sine 360 also 0. Okay, so therefore sine 180 degrees you will get the value as 0. And for n is equal to 4, s suffix 4, sine 4 pi by 3. 4 pi by 3. So you will, that 4 pi by 3 we can write in the trigonometric ratios sine 2 pi plus pi by 3. Okay, 2 pi plus pi by 3. So if you simplify that, again you will get the same value only. So therefore that value you will get in this format minus sine pi by 3. Here sine 4 pi by 3 we have, that 4 pi by 3 we can sine of pi plus pi by 3. It is not 2 pi ma. So I have made one mistake while writing that value. Okay, so sine of pi plus pi by 3. So if you calculate pi plus pi by 3, you will get 4 pi by 3 only. So here sine pi plus pi by 3 is nothing but 180 plus theta. 180 plus theta exists in the third quadrant. Okay, 180 plus theta exists in the third quadrant. In the third quadrant, only tan and cot ratios only will get positive sign. Rest of the 4, sin theta, cosecant theta, cos theta, secant theta will get negative sign. Okay, so whenever you have angle 180 plus theta and 270 minus theta, here we have 180, that means pi plus pi by 3 we have. Okay, sin pi plus pi by 3. Here pi means 180 plus theta. 180 plus theta means third quadrant. In third quadrant, only tan and cot ratios will get only positive sign. Rest of the 4 trigonometric ratios will get negative sign. Okay, whenever you have 180 degrees, sine ratio will become sine only. Okay, so therefore you can see that value sine 180 plus pi by 3 you will get, that is exist in the third quadrant. Sine of the sine theta is equal to minus. Okay, minus sine theta, theta plus pi by 3. In the place of theta we have pi by 3. Again pi by 3 is nothing but root 3 by 2, minus is there, minus root 3 by 2. Okay, in that format. Okay, next for n is equal to 5, s suffix 5 is equal to sine 5 pi by 3. Okay, so that sine 5 pi by 3 you can write sine of 2 pi minus pi by 3. Sine of 2 pi minus pi by 3, that means if you calculate that value, 360 minus theta, fourth quadrant. 360 minus theta, fourth quadrant. In fourth quadrant, only cos theta and secant theta will get positive sign. Sine and rest of the angles will get negative sign. So therefore we are getting negative minus pi by 3 minus root 3 by 2. Here also angle is same, pi by 3. We are getting minus root 3 by 2. In this format, if you proceed to substitute small n is equal to any natural number, n is equal to from 1 to infinity, if you get the values, okay, after substituting the finite number of values in place of small n, you can observe that root 3 by 2. Okay, so here root 3 by 2, 0 is there, minus root 3 by 2, minus root 3 by 2. If you proceed in this format, same root 3 by 2, for the n is equal to 6, you will get root 3 by 2. Same values again repeating. Okay, so the sequence takes each of the values root 3 by 2, 0 and minus root 3 by 2. అవే వాల్యూసే కానీ రిపీట్ అవుతా ఉంటాయి ఒకదానికొకటి. ఇప్పుడు రూట్ 3 బై 2 రూట్ 3 బై 2 రెండు కన్సిక్యూటివ్ గా వచ్చాయి, తర్వాత 0 వచ్చింది, తర్వాత రూట్ 3 బై 2 మైనస్ రూట్ 3 బై 2 మైనస్ రూట్ 3 బై 2 రెండు కన్సిక్యూటివ్ గా వచ్చాయి. నెక్స్ట్ మళ్ళీ రూట్ 3 బై 2 రూట్ 3 బై 2 వచ్చిన తర్వాత 0 వస్తుంది, 0 తర్వాత మళ్ళీ మైనస్ రూట్ 3 బై 2 మైనస్ రూట్ 3 బై 2, ఇలా అది ప్రొసీజర్ అనేది రిపీట్ అవుతా ఉంటది అనమాట. కాబట్టి మనము ఓన్లీ వన్ టైం కే ద ప్రొసీజర్ ని కంటిన్యూ చేస్తాం. సో దేర్ ఫోర్ ద సెట్ ఆఫ్ సబ్సిక్వెన్షియల్ లిమిట్స్ ఆఫ్ ఎస్ ఆఫ్ ఎక్స్ ఎన్ ఈస్ ఎస్ ఈజ్ ఈక్వల్ టు, ఇక్కడ మనకు ఎస్ ఆఫ్ ఎక్స్ ఎన్ ఈజ్ ద మెయిన్ సీక్వెన్స్. ఆ మెయిన్ సీక్వెన్స్ కి సబ్ సీక్వెన్సెస్ ఏంటి, S1, S2, S3, S4 అండ్ SX5. ఇవన్నిటికి మనకి ఏమొచ్చాయి, డిఫరెంట్ వాల్యూస్ వచ్చాయి. ఆ వాల్యూస్ అన్నిటి ఎనీహౌ దిస్ సీక్వెన్స్ హ్యాస్ వన్ పర్టికులర్ లిమిట్ పాయింట్. SX అనే సీక్వెన్స్ కి ఒక ఖచ్చితంగా ఒక లిమిట్ పాయింట్ ఉంటుంది యాజ్ n టెన్స్ టు ఇన్ఫినిటీ. బట్ ఇక్కడ ఇండివిజువల్ గా రాసిన సబ్ సీక్వెన్స్ కూడా ఒక లిమిట్ పాయింట్ ఉంది. అవన్నిటిని కలిపి మనం సెట్ లో రిప్రజెంట్ చేసాం అనుకోండి, దట్ సెట్ ఈస్ కాల్డ్, నెగిటివ్ వాల్యూ ముందు రాస్తాం మైనస్ రూట్ 3 బై 2, తర్వాత 0, తర్వాత పాజిటివ్ వాల్యూ రూట్ 3 బై 2. ఓన్లీ ఈ 3 వాల్యూస్ డిఫరెంట్ గా రిపీట్ అయిపోయాయి అనమాట. ఫర్ n ఈజ్ ఈక్వల్ టు డిఫరెంట్ వాల్యూస్, అవే 3 వాల్యూస్ రిపీట్ అయ్యాయి కాబట్టి ఓకే, సో ఓన్లీ దోస్ వాల్యూస్ మాత్రమే రాస్తాం అనమాట. రిపీట్ అయిన వాల్యూస్ నేను రాయము. సో ఓన్లీ అది ఎన్నిసార్లు రిపీట్ అయినా ఒకసారి తీసుకుంటాం ఆ వాల్యూని. సో దేర్ ఫోర్ s ఈజ్ ఈక్వల్ టు మైనస్ రూట్ 3 బై 2, 0, రూట్ 3 బై 2. ఈ వాల్యూస్ సీక్వెన్స్ కి లిమిట్ పాయింట్ అవుతాయి. ఎట్ ద సేమ్ టైం ఆ సీక్వెన్స్ లో మనం n ఈజ్ ఈక్వల్ టు 1 2 3 సబ్స్టిట్యూట్ చేసుకుంటే సబ్ సీక్వెన్స్ కూడా లిమిట్ పాయింట్స్ అవుతాయి. దట్ ఈస్ కాల్డ్ ద సబ్సిక్వెన్షియల్ లిమిట్ పాయింట్స్. నేమ్ లోనే ఉంది సబ్ సీక్వెన్షియల్ లిమిట్ పాయింట్స్ అని చెప్పేసి, అంటే సీక్వెన్స్ కి లిమిట్ అవ్వాలి, సబ్ సీక్వెన్స్ కి లిమిట్ అవ్వాలి. సో దట్ ఈస్ ద సబ్సిక్వెన్షియల్ లిమిట్ పాయింట్. దిస్ క్వశ్చన్ హ్యాస్ ఆస్క్డ్ ఇన్ ద ప్రీవియస్ ఎగ్జామినేషన్. సో ఫర్ ద షార్ట్ ఆన్సర్, వెరీ ఇంపార్టెంట్. నెక్స్ట్ సెకండ్ క్వశ్చన్. Okay, second question is also sequence is same, s of x n, and the trigonometric function has changed, cos n pi by 3. Okay, so now for n is equal to 1, s of x1 cos pi by 3. Cos pi by 3 means cos 60 degrees. Okay, cos 60 degrees is opposite to sin 60 degrees. Okay, sin 60 degrees is root 3 by 2, cos 60 degrees is equal to 1 by 2. Okay, so next for n is equal to 2, s2 cos 2 pi by 3. That value, if you simplify that, 2 pi by 3. Okay, so 2 pi by 3, if you simplify that you will get 120 degrees. Okay, so therefore 1 by 2, if you simplify that value, you will get minus 1 by 2. For n is equal to 3, s of x is equal to cos 3 pi by 3. 3 will get cancelled, cos pi value is equal to minus 1. Okay, cos 180 degrees. For n is equal to 4, s of x 4 cos 4 pi by 3, you will get minus 1 by 2. This value also, this 4 pi by 3 also we can write. Okay, cos 4 pi by 3 is there, cos of pi plus pi by 3, cos of pi plus pi by 3. So it is in the format of cos 180 plus theta, cos of 180 plus theta, 180 plus theta. 180 plus theta exists in the third quadrant. In the third quadrant, so cos will be negative. Okay, in the third quadrant cos will be negative, so therefore minus, whenever you have even angles, so the same ratio will come, and theta. Okay, so therefore minus cos, in place of theta we have pi by 3. Okay, cos pi by 3. What is the cos pi by 3 value? 1 by 2. In this format we can get the values. Okay, for n is equal to 5, you will get 1 by 2, cos 5 pi by 3. For n is equal to 6, 6 pi by 3, 3 1s are 3 2s are. Okay, so 2 pi means cos 360 degrees. Cos 360 degrees is plus 1. Okay, next for n is equal to 7, s of x 7 is equal to cos 7 pi by 3. That is also 1 by 2. If you observe carefully, all the values from n is equal to 1 to 7, 1 by 2, minus 1 by 2, minus 1 and plus 1. Okay, so if you observe carefully, for n is equal to 8 also will get minus 1 by 2 only. If you proceed in this format, okay, so after finite number of steps, the set of subsequential limits of the given sequence s of x n is equal to, we can write only repeat అయిన values లో ఒకటే సారి రాస్తాం. minus 1 అనేది repeated, minus 1 by 2 repeated, 1 by 2 repeated, 1 repeated. ఆ values ఎన్నిసార్లు రిపీట్ అన్నావని. ఓకే, సో ఓన్లీ వన్ టైం మాత్రమే మనం వాటిని తీసుకుంటాం. ద సెట్ ఆఫ్ దట్ టోటల్ లిమిట్ పాయింట్స్ ఈజ్ కాల్డ్ సబ్సిక్వెన్షియల్ లిమిట్. ఇందులో మనకి ఏదో ఒకటి సీక్వెన్స్ కి లిమిట్ అవుతుంది. -1 కావచ్చు, 1 by 2 కావచ్చు, 1 కావచ్చు, -1 కావచ్చు. ఓకే, సో యాజ్ n వాల్యూ టెన్స్ టు ఇన్ఫినిటీ, ఆ సీక్వెన్స్ అనేది ఏదో ఒక లిమిట్ పాయింట్ ఉంటుంది. అదే లిమిట్ పాయింట్ మనకు సబ్ సీక్వెన్స్ కూడా అవుతుంది అనమాట. సో కలెక్షన్ ఆఫ్ దోస్ ఆల్ సెట్స్. సో యూ కెన్ రైట్ ప్లస్ ఆర్ మైనస్ 1 అండ్ ప్లస్ ఆర్ మైనస్ 1/2. సో దట్ ఈస్ కాల్డ్ ద సెట్ ఆఫ్ సబ్సిక్వెన్షియల్ లిమిట్ పాయింట్. సెట్ ఆఫ్ సబ్సిక్వెన్షియల్ లిమిట్ పాయింట్స్ అన్నమాట. Okay, so in this format, if you get any question based on this subsequential limit format, so just you have to take the sequence. In that sequence, for in place of wherever you have small n in the sequence, wherever you have small n, otherwise if you get another variable in place of instead of small n, if you get x comma y, in place of any variable you have to substitute the natural numbers, okay, or positive integers. So for n is equal to 0 or n is equal to 1, whichever value if you start that, so the total after completion of the n is equal to 7 or n is equal to 8, that means a finite number of substitutions, you can realize that some values are repeating. Okay, so therefore those values only we are writing in the set of collection of numbers. Those numbers are called limit points. Those limit points are the subsequential limit points. Okay, so ఈ ఫార్మాట్ లో మీకు ఎగ్జామ్ లో ఈ ట్రిగ్నోమెట్రిక్ ఫంక్షన్స్ కాదు, మీకు మెటీరియల్ లో కానీ సియా పబ్లికేషన్ రియల్ అనాలిసిస్ మెటీరియల్ లో అండ్ టెక్స్ట్ బుక్ లో కూడా చాలా ప్రాబ్లమ్స్ ఉన్నాయి సబ్సిక్వెన్షియల్ లిమిట్ మీద. సో ఈ కాన్సెప్ట్ ని బేస్ చేసుకొని మీరు వాటిని కూడా ప్రాక్టీస్ చేయండి. ఖచ్చితంగా మీకు డెఫినెట్ గా అప్కమింగ్ ఎగ్జామినేషన్ లో సబ్సిక్వెన్షియల్ లిమిట్ పాయింట్స్ నుంచి డెఫినెట్ గా క్వశ్చన్ మీరు ఫేస్ చేస్తారనమాట. ఓకే, అండ్ డోంట్ ఫర్గెట్ టు రైట్ డౌన్ ద డెఫినేషన్ ఆఫ్ ద సబ్సిక్వెన్షియల్ లిమిట్ పాయింట్స్. ఇట్ ఈస్ వెరీ వెరీ important. So this is the total explanation of the subsequential limit point. Okay, so I hope you understood this problem very well. In the next lecture we are coming with another important topic. Okay, so make a perfect practice, prepare well. Until bye, thank you.